In the last video, we were able to plot the area that was bound by two curves in MATLAB. And in this video, what we're going to do is we are going to compute the area bound by the functions. All right, so it's the same functions that we had before. And just as a brief reminder, we had the function x cubed plus 2x squared and 3x. And what we did was we just went through and we just plotted them. And now what we can do is we can find the area that's bound. Now, remember, when you're dealing with two areas, like in this picture, the equation that we're going to use for the area bound by two curves is we're going to find the integral from a to b of f of x minus g of x dx. Right? Now, remember, f of x is the top function or the larger function, and g is going to be the bottom function. And so there's actually two areas that we have to compute in this problem. All right, so and we can pretty much see that in this case, the top function, at least for area 1, which is going to be the larger of the two, is going to be the cubic minus the linear. All right, so and I'm just going to write these out first, and then we're going to program it. Okay, so I'm just going to call a sub 1 equal to the integral. Remember our points of intersection that we found in the previous video by using the solve function, -3 to 0. All right, so we're going to say this is -3 to 0. Our top function is going to be the cubic, which is going to be x cubed plus 2x squared. So that's our top. And then the bottom function is 3x. Right? Now, area 2 is going to go from 0 to 1. All right, and again, we can see that our limits of integration right here from the points of intersection are 0 to 1. And we can see in the diagram that the linear function is now the top function and the cubic is the bottom function. So 0 to 1 of 3x minus the x cubed plus 2x squared dx. All right. And of course, the total area is going to be the sum of the two areas that are given. All right, so let's go ahead and plot this or figure this out with MATLAB. Okay, so what I'm going to do is I've already plotted the the curve. All right, just went away. I don't know where it went. Just ran away. So what I'm going to do is I'm going to go ahead and clear my x variable, and then I'm going to do a sims of my x variable. All right. All right. Now remember, x had some values stored in it before. All right, so we want to get rid of those. So that's why I did a clear x, and then I did a sims x. All right, and realistically, if I wanted to clear all, I could do that. Now I'm going to call a1, and remember, a1 was going to be equal to this integral. All right, so let me switch screens, and we can see we go from -3 to 0 of this integrand. All right, so that's going to be x cubed. So a1 equals the integral of x cubed plus 2x, and remember it's 2 times x squared minus 3 times x. We're going to integrate that with respect to x from -3 to 0. All right. Now let's just run this. Okay, I'm just going to put some spaces in here, not that we need it. Let's just run this to see if we can get an area out of this. So I'm going to go ahead and run it, and hopefully the graph comes back. All right, so here's our area right here. Okay, so pretty cool that we got an area out of this. All right, not sure what happened to our graph. It ran away, but let me see if I close this. So maybe I can go ahead and close editor file. Okay, so it was right there. All right, so we need to open the editor file again. So let's close the figures. And not sure what happened with that. I'm just going to open up the file again. All right, so anyway, all right, so let's now go ahead and figure out what the integral for a2 was. Okay, so a2, and remember the second area was this 0 to 1 of 3x minus x cubed plus 2x squared dx. All right, so a2 is going to be the integral of 3 times x minus x cubed minus 2 times x squared with respect to x from 0 to 1. All right. Now remember, we got 54 or 45 fourths for the first one. All right, let's run this animal. All right, we get 7/12 for that. All right, and then here's our figure again. Mysteriously, it appears again. We want a total area. All right, so we're going to say the total is going to be equal to A1 plus A2. All right, and if we run that, that should give us the total area. And I'm going to format this nicely. So here's our total area, 71/6. Now I'm going to suppress all these. All right, I don't really care about any of those except for total. And I'm going to get myself a nice output statement. So I'm going to say fprintf, okay, and I'm going to say apostrophe, the total area, or you can say the area bound is, and I'm going to say %s, and I'm going to use /n. I'm going to get outside the apostrophe, and I'm going to say comma total. All right. So now what this means is that %s means that I'm expecting a string, and it's going to read whatever the value is in total. All right. So it should print it out as a fraction. So let's go ahead and do that. And then I'll show you what happens if I decide to change the data type. All right, so there it is. The area bound is 71/6. Okay, and we could say the area bound for problem 1 if we really wanted to. Now, if I wanted to get a decimal approximation, I could use %f. Right, so let's see how that changes it. Obviously, we're going to change the message a little bit, but let's run this. All right, and notice this time it gives it to you in a percentage, or I'm sorry, in a decimal. All right, so I would suggest, if at all possible, using %s, so that way you can get an exact value out of this. All right, so this is a really cool sort of little program because now you can actually see what the area is, but we've actually programmed it so that we can compute the area between the two curves. All right, so hopefully this helps you to be able to see how to use MATLAB to be able to get through some of these rote computations. All right. In our next videos, we're going to take a look at a few of the other geometric applications of our integrals.